Hey everyone, Tim DeStasio here, Psychrometric Saturday once again, and we've been talking about enthalpy and total heat and how total heat is broken up into two parts. Now the sensible heat load is how much BTUs per hour it's going to take to control the temperature in the building to our desired set point. The latent heat load is how many BTUs per hour it's going to take to control the humidity levels to our humidity set point. So when we are trying to match the proper HVAC equipment to the load, we need to pay very close attention to both the sensible and the latent heat. And here's how manufacturers rate their HVAC equipment. They use a sensible heat factor, and that's when we take our sensible and we divide it by our total. Let's take an example. We've got a load calculation already done, and hopefully before you are selecting HVAC equipment, you've already done a load calculation. Out of our load calculation, we've got 32.5 MBH. Well, what is that? Well, a lot of manufacturers, instead of using 32,500 BTUs, they call it 32.5 MBTUs per hour, 32.5 thousand BTUs per hour. So that's what we've got in our load, 32.5. Out of that 32.5, 27.4 MBH is sensible. The next thing we need to do is determine what our sensible heat ratio is. And to do that, we've got to take our sensible heat and divide it by our total heat. When we divide 27.4 divided by 32.5, we come up with a sensible heat ratio of 0.84. Sensible heat ratio. And all that's saying is, out of the 32.5 MBH of total load, what percentage of that is sensible load? And in this case, it's 84%. That means that the remaining 16% must be latent load, and that works out to 5.1 MBH of latent. So what we're trying to do as designers and contractors, we're trying to match a unit that will perform very similar to those numbers right there. But we don't live in a perfect world, and sometimes those numbers fall between two different equipment sizes. So let's say, for example, and we are stuck between a 2.5 and a 3-ton system. As we can see, each performance chart has some airflows that we can select, and as those airflows go up, notice what happens to our total MBH. Well, they go up as well, and that makes sense. If we're moving more air, we're going to be doing more air conditioning work. But notice what happens to our sensible heat factor. That is similar to our sensible heat ratio. It's the ratio of sensible to total heat, or the percentage of sensible heat to total heat. And notice as our airflow goes up, this number goes up. And that also makes sense. The higher our airflow, the less dehumidification, the less latent we're going to do, and more sensible work is done. So as we go up in airflow, these numbers tend to go up. So we're trying to match our total capacity to our total load. Well, between this 2.5 and this 3-ton unit, we have several that are pretty close. We probably don't need to worry about our 2.5 ton at 900 CFM. That's not even close. 29.5 isn't even close to 32.5. We probably don't even need to worry about our 1,000 CFM at that 2.5 ton unit, because we're not getting anywhere close to that total BTUs. But we start getting close with our 2.5 ton unit at 1,100 CFM. 31.9 gets pretty close to 32.5. And then as we move into our 3-ton unit, we get really close. 32.9 is pretty close to that, but we've overshot. And as we get into 1,200 CFMs, we start getting a little bit farther away from that. And definitely a 1,350, we are way apart from that 32.5 load. So we can probably cross that one out. So really, we have a decision to make. We either try to run a 2.5 ton unit at a higher airflow, or step up to a 3-ton unit. Well, what are we going to do? That's a pretty big decision. Are we quoting a 2.5 ton unit or a 3-ton unit? I know I threw a lot of numbers at you. We'll be working on this some more. Thanks for joining us on Psychrometric Saturday.